SK picture, which is an encapsulation of a series of draw commands for deferred rasterization. The history of deferred rasterization, as I understand it, was to support fast touch scrolling on Chrome for Android. And so if tiles aren't changing, you can render again quickly without having to paint those again. All right, developing on Skia. So recently, earlier this year, we launched Skia.org. We had always had Skia.org pointing to some of our other sites, but we actually did a revamp of the website, and we have it hosted with many subdomains so that hopefully you can use a subdomain Skia.org for anything that you need Skia. And it's starting to become so proficient that we're guessing Skia subdomains, kind of like Go links, as far as what you can get to. So the code and the docs are in our Git repo. That was another recent change. We moved the docs to Markdown format. Now they're hosted in the source alongside the code. So if you have any updates to the docs, you can go ahead and submit a CL. Anybody from the public can submit a CL. We can review it and get that in. Bugs, you can do bug.skia.org, or you can use skbug.com, much like crbug.com. Our bugs exist in both places, and I put up here some labels that you might be able to use. In Skia, we're starting to use good first bug as a label to show where you could start to pitch in on Skia or learn a little bit more about Skia if you'd like to try to fix something. And then CR internal Skia and internals GPU rasterization. Those are the primary components in the Chromium database where you'll find bugs related to Skia, or where you can file your bugs related to Skia. All right, developing on Skia further, we've got Skia Fiddle. Much like JS Fiddle, we launched Skia Fiddle as a site that you can use to put up some sample Skia code and see what the output will be. So it's a C++ compiler running, it's sandboxed and now secure. It was down for just a little bit while we were making some security updates in partnership with the Chrome team. You can compare the output of CPU, GPU, and also PDF. That's the small square down there, which I think you have to download to see it. But those are the kinds of output you can get and see if they render much the same. We use this now as our primary bug repo utility. And so often in bugs, I'll be asking the community to submit a fiddle that shows us the problem. And you can also file bugs directly from Fiddle. There's a little report bug spot right above those renderings that'll directly link a bug and has a template already launched for a Fiddle bug. And they're also embeddable in the documentation. So this is our plan forward, to use these for samples and tutorials and bettering our docs for Skia. All right, now I wanted to talk a little bit about our current focus, some of the things we've been doing recently, and then the roadmap moving forward. So if you went to the Slimming Paint talk, you heard about Skia a little bit. We're definitely, one of our primary focuses is working on Slimming Paint. We're also working on Ganesh everywhere. So we use Ganesh in a number of places in Chrome, but we're trying to further that and benefit from that acceleration. Correctness and precision, always one of our focuses. Performance, again, always something that we're focused on, but more than ever now. And image decoders and new APIs and platforms. I'll talk a little bit more about that. All right, Slimming Paint. So Slimming Paint basically changed our paradigm. As we were looking at SK pictures, we were used to having a small number of huge pictures for a page, and now we're dealing with a huge number of small pictures. And so there were some performance costs associated with that. And so much of our work in the last quarter has been on improving that for the Slimming Paint story, improving the picture recording for small, nested, and empty pictures. So now when a small change occurs to a page, such as Mona Lisa's earbuds, you can change that without having to, you can replace just a few small SK pictures instead of having to regenerate a huge SK picture. So that's the benefit that they're seeing out of the small pictures. Okay, GPU acceleration. So we've been working on, this is also called Ganesh, as you may have heard earlier. That's the code name for that side of our library. Distance field fonts. If you work with distance fields at all, it's a method of getting better, crisper fonts that can be easily manipulated. We have had an interesting relationship with the Chrome enablement lately, and it was enabled, and then I think it was disabled for some quality concerns, and we revisited things, enabled, disabled. I think it's about to be on again in Chrome and hopefully to stay for Android. We see fast font rendering, especially when zooming with distance field fonts. And then we're also finding that for large glyphs, distance field is faster than paths. There's been further text context refactoring in Ganesh, and we're trying to take advantage of text blobs, which I'll talk a little bit more about in a few slides. This also works well in conjunction with distance fields, and we're looking at this Skia Blink partnership work together is to make more and bigger text blobs so that we can take advantage of these wins. Okay, GPU draw reordering. So if you're familiar with Alice in Wonderland, instead of jam, we're saying triangles tomorrow and triangles yesterday, but never triangles today. So if you look at an SK picture or display list, you have an operation, and then you have to do that in this part of the screen, which would be the triangles here. In our old code, you would just generate all of that at the same time. And in the new code, you actually break this apart a little bit, generate the operations list, then reorder those operations, group like things together. We recently launched a class called GR Batch, and then generate the triangles so that you can make sure that you're reusing whatever can be reused and minimizing your draw operations where possible. Yes, I guess I kind of mentioned this, reorder and group the operations, fewer state changes, fewer draw calls. We generate the vertices after a reordering pass. Also, this reordering, along with some work being done on deferred tessellation, is supposed to open up possibilities for multi-threading, like multi-threaded geometry generation. We know that Android does this and believes it gives them significant performance benefits, and also a number of game engines use this and benefit from it. So we're going down the same path. All right, further, per target draw lists. So by having per target draw lists, Chrome can draw a bunch of tiles for pre-raster, and then we can selectively flush only the tiles that the compositor wants to commit to. And we can also discard or hold off on flushing pre-raster tiles. All right, correctness and precision. So our focus on these things, we've been making improvements to both the code and to our infrastructure. And this is kind of interesting because these conversations have been coming up a lot in Blink as well, I know, with the layout tests and where we're going to keep them and how we're going to use them. So we have Skia Gold. It's our interface for our diamond, what we call DM, Diamond Master tests. Each Skia commit generates hundreds of thousands of traces, and these traces are what we call a unique combination of test, platform, backend, color type, a number of other parameters. We maintain a set of images for each test, and then we synchronize that with our code base. So historically, we've gone through a number of changes as to how we handled these tests and where we kept the images. First, we had the images checked into source control, and then next we moved to the images are no longer checked in, but digests are. So we had expectation files. And then today we actually have nothing checked into the code repo. If you're interested, I have some more detailed slides, or I can hook you up with one of our infra engineers about exactly how this works. But I think they're in a lot of conversation with at least the Chrome team and perhaps a few folks interested in Blink and finding out if this might work for Blink as well. And I should comment that not only for Blink, but if you're representing some outside product, our tools, Skia Gold for correctness and Skia Perf that I'll mention, all the code is in our open source repository and it's pretty reusable. So we've had some other products in and outside of Google that are looking at using the tooling as well for their testing. So you're welcome to check it out. So this is what the web app for Gold looks like. It's at gold.skia.org. And if you go to gold.skia.org, you might initially see a little bit of a different looking screen because we're actually in the process of launching our V2, which is based on Polymer. So these are some early screenshots of what V2 looks like. And I believe you have to add V2 to the URL to get this view. But the first view shows you just all of the test names, and then you can get numbers on positive, negative, untriaged, and total images coming through for those tests. And so we look at this, and we also have an alert server that's paying attention to this, especially so that we can see what comes through as untriaged, which are new images, and determine whether those are positive or negative, and go through the process of fixing them. You also, within Gold, can specify a number of parameters and filter on anything that you'd like to see. So that can be done free-form text, or you can choose different things in these categories. I'm actually not sure why a lot of these are empty because they're usually full of many different options. Perhaps it's the new interface, still under progress. And then if you deep dive on a particular test in Gold, you can actually go in and see the latest images and focus in on an image. The first thing that the interface will give you is the closest positive image to that untriaged image that you're looking at. And then the next thing will be a pixel diff showing you what was different about it. Also in the center are some point diagrams and listings of probable CLs where this image has been seen. And then over to the right, you get the buttons, you get all the parameters on the platforms and all other aspects of the config. And then you get your buttons to say this is positive, this is negative, or leave it as untriaged. And then also each digest has its own page where you can open that up and see everything about it. Okay, so actually in the code about correctness and precision, first we've been moving to floating point math. So I'm not going to get into a lot of detail here, but if you're interested, we've been changing things under the covers and finding that we're not only improving accuracy going from 8-bit to 16-bit, but sometimes actually seeing performance improvements as well. So we have some new classes out there that are called SK-NX, like SK4X, for example, and they're being used in geometry and matrix math now in Skia and showing some big wins. We've also been going through a big rewrite of paths, conics, strokes, and improving the code there, mostly for accuracy, but then also for performance. So stroking now uses quadratics to describe the inside and outside of a stroked curve. And the stroker has access to the device matrix, so it can compute the error term and keep the stroke edges accurate to a quarter pixel. We've over the last maybe year or two, moved from a pixel to a half pixel to now a quarter pixel accuracy. And you can see the an example here. This was from a Chromium bug that was recently fixed as a result of this updated precision. Oh, and then with the path rewrite, I should mention, we've been going through path ops. Carrie Clark on our team loves path ops and determining how you can best understand a path and render it. So he has been making some changes there as well. I think in the last, in my February-ish Skia update, we were at a 6 times performance improvement for a lot of use cases. And now in the last week, Things there are even 50% faster than they were at that time. Okay, text blobs. So historically, Blink used transient glyph buffers. During each paint phase, there were some problems with this. Text had to be shaped into stack allocated glyph buffers every time it was recorded. There was API friction converting glyph buffer data to something that was a Skia compatible format. And then there was also lack of persistency. There was really no efficient way to identify a recurring text sequence and cache it. So this is what we're trying to achieve with text blobs and minimize those draw text calls. So here's pretty much the first picture is where we are today. The second picture is where we hope to be very soon, as far as the type of text that's being grouped together and cached. And text blobs have a lot of benefits. I've listed some of them here. One thing that we're really benefiting from here is caching the result of the text shaping. And as I mentioned with the API friction, it's in a format directly usable by Skia. So you can construct these at paint time in Blink, and you can call draw text blob as the API for doing them. And we hope soon to have greater groupings of text, and then even longer term, have this picture be one entire text blob. Okay, Skia Perf. So from a performance perspective, this is infrastructure as well. This is our performance tooling and web interface. Here's a view of what you get on the alerts page. Any change that creates a step function in our background code shows up on here, whether it's a step up or a step down. So we see everything is technically called a regression in this interface, but we see whether it has gotten worse or also things that have gotten better, so that we can triage them and make sure they really got better, or understand what's going on there. So the bolder view is something that is new and has not yet been triaged. The things that are grayed out below are ones that have been triaged, and you can click and deep dive on this, make notes about why you think that this is occurring. This is, as you can see in the URL, maybe it's at perf.skia.org. Then the dashboard of perf actually gives you a view of all the traces, what they're all doing, so that you can kind of deep dive into either one of the alerts or just any other test you'd like to see. It gives you a number of parameters over to the right, much like Gold does. And then at the bottom there, if you were to scroll down some, you see a blame list of the CLs associated with this change. And you can click on the traces and see the CLs as it goes. So you can get a view here, and also in our analysis tools, you can do operations on traces and comparing traces against one another, and you can kind of get an idea of how noisy a test is, or whatever else you need to look at to understand those traces better. Cluster telemetry. So also for slimming paint, we've been changing our cluster telemetry to support that initiative. We have 100 servers with GPUs. We have 100 Nexus 5s for mobile representation. We have you can run the telemetry on up to 1 million web page archives. I think there's options for 1,000, 10,000, 100,000, and 1 million, depending on what you're looking for. And those archives are grouped and based on the top Chrome pages, Android, key silk pages, the slimming paint page set, all those kinds of things. And for the cool factor, the team recently rewrote this in Go. All right, image decoders. So this is one of the new things we're doing, the new APIs. We started doing this actually in support of Android, who today uses Skia's image decoder. So that's why I've got Skia and Android in the same box together. Then we have Blink and Chrome in this picture. And so we were looking to update Androids and make them better. And as we were in process of doing that, it came up that it might be a good initiative to try to converge as much of the codecs as we could so that Blink Android and potentially Chrome can use the same. So here are a lot of the goals around doing this and the things that we're hoping to make better. We're hoping to support different color depths, alpha types, color profiles, everything that is required in the Blink image decoders, the Skia image decoders. And then also the reason it's a little bit grayed out is because we're looking at the Chrome, PNG, and JPEG codecs and seeing if those needs can also be met and built into this new API. We're still working on PDF, so our PDF APIs are still kind of cleaning those up and growing them where they need to be grown. We've recently improved memory utilization by around 50%. We added, or we're in the process of adding PDF-A support, which is an archive support that I think is being mandated by government clients. Work to integrate Skia with the PDFium rendering code. This is where we're hoping to converge some of what Skia does today and what PDFium has in that code base and hopefully make it better. iOS support. So this is something that a number of our clients have been asking for and that Chrome's been looking at. We have always compiled on iOS, but never paid a ton of attention to it, honestly. And so now we have dedicated test bots coming online so that we can maintain our support on iOS and hopefully support some new clients that have come our way. Ganesh and Chrome. So Ganesh is primarily enabled on mobile, Chrome on mobile, and we're now working to, there are a number of triggers and filters, vetoes and things that determine what Chrome content gets rendered by Ganesh. And so another big initiative for us is expanding that enablement and allowing Chrome to benefit from Ganesh on all platforms. And so next, coming up, we're working on Mac, hopefully, and I think this next milestone for that enablement to happen. And then next gen high performance graphics APIs. So we've been doing a lot of changes to the Ganesh backend for many reasons, but one of them is also kind of looking at the horizon, what's coming out there in addition to OpenGL and how we're going to address having Skia backends to support those APIs. In other news, font collection support, we recently did that. We're working on multi-master font support, shareable pictures, and C++11. A couple of things hot off the press. We've got SK Picture Shader. This basically enables features that historically employed record time rasterization. They can now be represented in a resolution independent format. And then we've got some more work to do in Ganesh in this area. I think several Blink features are now implemented with picture shaders, SVG image patterns, generated image patterns, image spacing. And then SK Drawable. This is where we're building a tree of mutable and immutable sections. And then hopefully you can change parts of recording without actually having to re-record. Android does this in their hardware renderer for material design animation and finds a benefit from that. Okay. So that's the main things I wanted to hit. Like I said, not very new news, but we're continuing to be maniacally focused on performance and correctness in Skia, and we have a list a mile long of things to do there. So we're going to keep going down that list and trying to improve our rendering, and obviously working really tightly with any Blink and Chrome initiatives going on. We have lots of new infrastructure, as I mentioned, for testing, and are willing to share that infrastructure. So if you have interest in any of that, please check it out. Skia.org, as I mentioned, we have perf.skia.org, gold.skia.org, status, fiddle, bug, alerts. There's many more. So check out our new interfaces there. The code, which I just realized 2 hours ago and opened debugging it myself, that I need to create code.skia.com, code.skia.org. The code is there at Google Source. Skia Discuss is our main public mailing list for questions and has a lot of beginners trying to work their way through our docs and our builds and running into issues, and a lot of questions answered there. And then I'm Heather, and that's my email address. I'm the TPM. I try to know most of what's going on in Skia, and I can send you to the smart people when you need to talk detail. So that's it. Any questions?